Okay, in today's video we're going to talk about function notation. So this is another word that was included in your vocabulary, and we haven't really had a chance to dig into this yet, and so we're going to go ahead and start talking about this. So function notation is just another way to write an equation, or that rule that we talked about in the last video that a function follows. Sometimes instead of writing it just as a regular equation, we write it as function notation. And so this would be a regular equation, y equals 4x minus 1. Function notation means that we just take that y and we change it to f of x. Okay, f of parentheses x, close parentheses. F is the name of the function, so you could see it written as g of x or t of x or whatever the name of the function is. In this case, we're calling it function, so we're going to call it f. And then x, of course, is the input. So any number that's inside of this is what you're going to plug in for the x value. But anything that is equal to this whole thing, f of x, that's actually your y value, because y is equal to f of x. Okay, so that might actually be a good thing for you to write down here in your notes. Y is equal to f of x. It's the same thing. We're just substituting a name change. Okay, and we read it as f of x. Okay, that's actually how it's read. So f of x is the output. It's the y, and x is still the input. Still that x value. Okay. So when we go to evaluate a function, okay, so here's the first thing that we're going to come across. If we know that this is the rule, that 4x minus 1 and negative 7 is the x, the input, then we're going to plug it in just like we've been doing. So f of x is equal to, okay, and in this case, it's 4x minus 1, and it's really, we've just found out, it's going to be f of negative 7. So now we're going to take that x and we're going to plug in negative 7 in place of it. And so then we're going to come right up here and solve. So f of negative 7 is equal to 4 times negative 7, which is negative 28, minus 1. And so f of negative 7 is actually equal to negative 29. Okay, and so the input here is negative 7. The output here is negative 29. Okay, so you can write your answer one of two ways. F of negative 7 is equal to negative 29. That means x value is negative 7, y value is negative 29. Or you can write it just like that as well, because remember that a function creates an ordered pair. Okay. And so now we're just going to do a few examples of this where we take that input and we plug it in. So this is very similar, it's just written differently than what we did yesterday. So same process as yesterday, just written differently today. So f of x is equal to x plus 5. We have been given that the input is 5. So we're going to plug that in. So f of 5 is 5 plus 7. So f of 5 is actually 7 plus 5, which is 12. Okay, so our value here is 12. That's our y value. Okay, and again, you could write it as that 5 comma 12. You could write it as f of 5 is equal to 12. You could even write it as y equals 12. Okay, you've got a few options there. All right, so the third problem here, we have h of 9 this time. And instead of the value x, instead of the variable x, we're going to plug in the value of 9. And when we multiply this, we're going to get 6 minus 1. So h of 9 is equal to 5. And then we keep working. So here we have f of, and instead of x, we have a 5. So we're going to plug in a 5 here. Plug in a 5 here. So 5 squared is 25, but there's an opposite symbol here, a negative, so we're going to call that negative 25. 6 times 5 is 30. And now just left to right. Negative 25 plus 30 is a positive 5, minus 4 is 1. Okay, so that's where our y value becomes 1, when f or when x is 5, input is 5, the output is 1. Okay, and then one more example here on the front side. We have a negative 5 this time. So f of negative 5, when we plug that in, everywhere we have an x, remember we use those parentheses so that we don't get messed up with our negatives. So negative 5 times negative 5 is a positive 25. Positive 25 times 2 is 50. 4 times negative 5 is a negative 20. Okay, and then we just simplify. 50 minus 20 is 30. Minus 9 is 21. Okay, all right. So all of those, we're just doing the same process as yesterday. We're just going to be changing the name from a y to an f of whatever the x value is. Okay. So now I'm going to skip. Actually, I'm not. Let's go ahead and do number 9. Okay. So on this one, instead of an input of a number, we have an expression. And nothing changes when we do this. We're just going to take this and plug it in every time we see an x instead of a number. So f of c plus 7. So instead of x here, I'm going to write c plus 7 plus 11. And then I'm going to simplify. And so I distribute. 4 times c is 4c. 4 times 7 is 28. And then I can combine 28 and 11. So f of c plus 11 is actually 4c plus 39. It's an odd answer. It's an odd thing, but sometimes that might be the information that you've been given. And so you just roll with what you've been given. So the input here was c plus 7. The output is 4c plus 39. We still follow the same rule. We still took that value and multiplied it by 4 and then added 11 to it. Okay, so we still did the exact same process. Okay. So now we're going to kind of play with this idea. We're going to continue working with it. So now we've been given, here's f of x, here's the function f, here's the function g, and here's the function h. So now we have 3 functions. And now we're going to be using that information here and plugging it in. So it's a little bit different. So here we have f of 4. So we have to know what f of 4 is. So we're going to start with f of 4, and then we're going to worry about this plus 9. So f of 4 is going to be 8 minus 3 times 4. Remember, we plug in that value. And 8 minus 12 is negative 4. Okay, so when x is 4, y is negative 4. Okay, so the value of f of 4 is equal to negative 4, so now I'm going to take that and plug it back into this. So I end up with negative 4 plus 9. Okay, that's all that I did. I found out what f of 4 was, and it's negative 4. Now that I know that it's negative 4, I plug it in right back here into this value. So instead of f of 4, I'm going to write it as negative 4 because that's what the value of it is. Okay, so negative 4 plus 9 is 5. So final answer on that is 5. All right. And so we're going to look at this a little bit differently. We're going to do a couple more examples so you can kind of have some additional practice. So here we have g of 4 and g of negative 1. Well, I got to find out what these two things are first before I can combine them. So let's do g of 4. So here is g of 4. We plug in 4 for x, and we get 16 plus 8, which is 34. Okay, and then we got to find out what g of negative 1 is. So g of negative 1, same function. We're just going to plug in a different x value. So negative 1 squared, and that's going to be a positive 1 minus 2, which gives us a negative 1. And so now that I know that g of 4 is 34, I can plug it in right here. So 34. And I know that g of negative 1 is negative 1. I can plug that in. And so I end up with 34 plus negative 1, which is 33. Okay, so just a few extra steps on these, but you're still doing the same process. Okay, So now we have if f of x is equal to negative 13, find x. Okay, so now we are given the y value, because remember f of x is equal to y, so y here is equal to negative 13. So if I know the output, now it's asking me to find the input. Okay, so here is my f of x, my function for f. So if f of x is negative 13, that's what I'm going to plug in. Negative 13 is equal to 8 minus 3x. X is now what I don't know. So I'm going to undo everything and solve for x. So I subtract 8, and I get negative 21 is equal to negative 3x, and then I didn't leave myself enough room, so I'm going to bring it up here. Okay, and I have negative 21 equals negative 3x. I divide by negative 3. And so x is equal to 7. So when the output is negative 13, the input is 7. So we can even work backwards on these. You don't always have to have the x value. Sometimes you're given the y value. Okay, and so you'll have opportunities to practice a little bit with this on 12, 14, and 16. Notice that 16 is another example where you're given y and you need to find x. Okay. All right, couple of last problems to look at here. I want you to attempt the application problem on your own, but I'm going to help you get started with it. So anthropologists use the length of certain bones of human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x is equal to 61.41 plus 2.32x can be used. Okay, so here's our function. And it's asking you to find h of 46. Which means the length of the femur is 46, so how tall is the female is what it's asking, okay? So you're going to do h of 46, and you're going to plug in 46 here. You're going to solve that, okay? And then you're going to explain. All right, 46 is the x value. X is the length of the femur, and the height of a female right here is your h of x. So if the femur is 46 inches, then what is the height of the female? And that's what you're going to find out when you solve this. Okay, so the height of the female is, and then you're going to answer it. All right, so the height of the female with a femur length of 46 centimeters is blank centimeters. Tell me how tall she is. So think about that. If the length of the femur is 46 inches, well, the answer has to be bigger than that, okay? You're going to have someone taller than 46 centimeters if their leg itself is 46 centimeters, okay? So keep that in mind. So you're going to solve this and plug your answer in right here, okay? All right, last two questions. We're going to do just a couple of these. So given the graph of f of x, here is the graph. Instead of being given an equation, you're given a graph. Find the function value. Okay, so if x is negative 3, okay, if x is negative 3, so here's 1, 2, 3, here's negative 3. If x is negative 3, what is y? And it's right there. It's that point where the x value on the graph, where the x value is negative 3. And so in this case, it is negative 3, positive 2. Okay, so the y value here is 2. Okay, one more example of that one. So if the input is 1, if x is 1, that means we're looking at this line right here. Where does it cross? Right there. So it's also at 2. And you'll do the same thing for C and D. Okay, and then 19, I'll help you with that one as well. We'll get started on that one. If x is negative 4, so negative 4, what's the y value that corresponds with that on this graph? So 1, 2, 3, 4, here's negative 4. We're looking for the spot that crosses this line from the graph, and in this case it's 2. Honestly, I didn't even think they were all going to be the same, so sorry about that. We'll try to pick something different this time. All right, so this one, If x is 0, all right, here's the 0, x is 0. It's going to be on this line. What's the y value for that coordinate right there? Also 0, okay? So that's what you're going to be doing. You're looking for those points that cross that value on that x coordinate, all right? So if you have any questions, let me know. Finish out the rest of those example problems. You're doing all of the C and D for 18 and 19. You're finishing number 17, and you're doing the evens. So 2, 4, 6, 8, 10, 12, 14, and 16, okay? Remember, send them to me. If you want me to check them, I'll be glad to do that. That way, make sure you're on the right track. If you have any questions, just send me those questions, and I'll be glad to answer them for you.